Is it good pen? Okay. You get to wear the hood. I don't want it. I'll use it later, maybe. Okay, anyways. Hello, everybody. Welcome to Great Math number 23 with me, JP. And today we're going to do square roots. Yes, my friends, square roots. Which is finally another purpose to actually use those powered by 1, 2, 3, 4, yeah, all those numbers. So let's start. So A. So just in case you don't know what a square is, well, let's say we're trying to find one square. Well, first of all, what is squared? Basically, it's the you know how we do 9 like this? The opposite is 9 squared. You get me? Because that doubles it, and then that's reverses it. So what times what equals 9 is for this one, and what 9 times 9 equals to what number? That's what we're looking for on this one. So it's kind of like the same, but it's the opposite. Oh, dang it, I forgot. Eraser. Oh, I'm going to have to do this to our good board. I hate that. I wish I brought an eraser here. I forgot to bring my eraser.
Go to pick up the eraser.
I forgot to bring my eraser. That's the only bad thing. I think that says Lord escaped. Yeah, anyways. Okay, so time to solve this equation. Thank you, sir. Thank you, sir. Okay. Alright, this is why on new ones you don't want to make them so bad. Yeah, you don't want it to make them so bad. I'm sorry, guys. Okay. So to solve this question, we are asked, how do we even go to it? So it's like a normal equation, but what is bugging you in this? The answer is the square root. Most likely is your answer. Well, how do we get rid of square roots? Well, what's the opposite of a square root? It's kind of like the reciprocal. How do you change the reciprocal? You use the reciprocal of the number. Yeah, if you want to change 3, you just need to do the reciprocal of the number. So this one, we just need to use squared. We need to square it. So some of you guys are like, hey, how do we square? And I'm like, it's like you just use the square by doing this. You just do that. Now you'll think, oh, okay, that's how you do it. And then you'll think, what in the world will this be? What's that? Well, it's the same thing as this. It's the same thing. They're the same thing. Yeah. They're the same thing, just to make you guys sure. So we'll square these two. And after that, it will be 9 plus 4y equals to 121. Which you do know. Yeah, 11 times 11. 11 times, yeah. And then we isolate the variable. Minus 9 on both sides, sorry. Minus 9. Minus 9. Then that will be 4y equals to 112. Yeah, or just measure. Yeah, okay, yeah, that's it. And then how in the world? Now we leave the variable by itself. Oh wait, whoops. Why still there? And then I'm pretty sure that's divisible by it. So we'll use 2. 3, 2, 8. Just 8. Yeah. So dividing it by 4. So in this question, y equals to 28. Yeah. That's our answer for this problem. Okay, so now we can take this out. Erase. See, and the new ones are so hard to erase. The only thing I don't like about this board is it's plastic up here. The other one used to be metal, but yeah. Okay, for B, now let's solve it. Okay, so if we want to do the square, we can't do it now. So we would have to do it later after we move this out, because then that would just be way too confusing. So let's minus 6 on both sides. I don't really have room here. Then that's minus square root of 6 plus 1 is equal to 3. Oh no, now we have to just get rid of that. Okay, so that's minus, multiply, -1 multiplied by -1. Cancel that. C plus 1 equals to -3. Yeah, we're done. What's that? Oh yeah, so I forgot to tell you this. A square root can never, I'll write that. A square root is never equal to a negative number. Okay? A square root is will never equal to a negative number. Okay? We got that?
My suggestion,
Okay. So that just makes us done. It's done. It's done. It's done. No more. We can't do anything else. Okay, so we got that down. Now let's do 9.31 of our
Can you rewrite the exercise there?
What exercise?
The next one, rewrite again the board on the board.
Yeah, I will. Oh, so 9.31?
Yeah, it's 9:31.
I will. I have to read it first. So 9.31, let's find it. Okay. So for each of the following, state whether the expression is positive or negative. A, 10 minus square root of 101. B, 10 minus 3 times the square root of 11. And C, 4 times the square root of 33 minus 5 by the square root of 21. This is my answer. Yeah, it's mine. Okay. So A is 10 minus the square root of 101. B is 10 minus 3 by the square root of 11. C is 4 by the square root of 33 minus 5 by the square root of 21. Okay, so what's that? Oh yeah, there's no square root of, you can't find a complete integer, the square root of 101, yeah. So we can't just go and find it because then that'll take forever. There's no integer, but then there's decimals, which then that might take forever, like I just said right now, yeah. Yeah, you're gonna think of square root of 2, square root of 3, it's just too hard. Another way we can do this, it's kind of like the last problem. We'll use squares. Now you're gonna ask, where is the equal sign? How can we do like the two don't play favorites? Okay, let's pretend this minus is kind of like a equal sign. That will help us. So, and yeah, and no, even if it's right or wrong, it will still tell us if it's positive or negative. It still tells us if the answer is positive or negative. So we square that, then we get 100 minus this minus 101. What's that, everybody? That's a negative number. So for A, it's negative. Okay, I'm just gonna write and P for positive, if there is any positive. If there is. There might not, there might be. We don't know until we find one of these problems that have positive. Anyways, to the next problem. Okay, so when we going to square this, we don't just square the square root. It's like a variable, it's like x. when you multiply by any number, you also have to attach it to whatever's multiplied by it. You can't take it out. It has to be with it. Okay? Equals to 100 minus 9 times 11, which is 99. What is that, folks? It's positive. Yep, that's positive. P, 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 pig. Pig, P, P, pig.
Do you need to put parentheses over there? 3 square root of 11.
So you need to do this.
Okay, okay, I see. Yeah,
Just
good
need
job.
to- yeah, thanks for reminding me. Anyways, do C. Let's do it. Okay, so how do we do this? Okay, so again, we use a square. We can't put emphasis here. Okay, so then that would be 16 times 33 minus 25 times 21. Uh-oh. Yeah, we don't know. We don't exactly know, so we will have to multiply this one. Yeah, whoop-de-doo. Multiplication. 18, bring up the 1, 3, that's a 4. No, wait, whoops. 3 times that, that's 3. Oh yeah, it is a 4. Whoops. Yeah, it's 4. And 3 times 6 is, yeah, it's the same thing. Add them up is 8. 2, bring up the 1, 5. Now for the next, you know what, you annoy me too much, Sith Lord. Ugh. Yeah. That's farther than I expected. Stop giggling in the background, people. Stop giggling in the background. Yeah, I'm talking about you guys. Yeah, not you guys. I'm talking about them. Yeah, you guys. Yeah, you guys. Good. Anyways, 21 times 25. That'd be 5. And that will be 10. That will be 2. And that will be 4. You add that together. That will be 5, 2, and that would be... Guys in the background! Stop it, please! Thank you, evil people. Yeah, okay. So now it shows that when we subtract it, it will be positive. Because, whoops. Yeah, it will be positive. PPP positive. It's 28. The answer will be 3. It is a positive number. Good, no more distractions. Yeah. So for C, it will be positive. Oh, positive. PPP positive. Okay. Next one. Let's do the next one. So we got this down. Let's do 942. It says here, evaluate, parentheses, opening parentheses is what I meant. Square root of 3 minus square root of 27 plus the square root of 75. Closing parentheses squared. Okay, I know what you're thinking. Wait, actually, you can't really think when you can't really see it. Unless you really followed what I was saying. Like most people. So I know what you're thinking. You're going to do like, oh, we can do it's equal to 3 minus 27 plus 75 because it's the same thing as squaring all of these. No, it is not. It just isn't. I'm sorry. It is way greater. You know A plus B squared? Remember we did that? That's A plus B times A plus B. That's A squared plus 2AB plus B squared. That does not look like A squared plus B squared. That does not look like that, does it? No, it doesn't. So yeah. So another way we can do it is doing this. 1, 3. 1 times 3. That's the same thing. And that will be, well, it's 1 times 1 times 9 times 3, which then using by doing the square root of it, of 9, that will be 3. So it'll be 3 times the square root of 3 plus 25. No, 5, sorry, 5 by square root of 3.
Because
When you do 20, because that's 25 times that 25, there's the square root of 25 is 5. Okay, so let's continue.
on 25 times 3 equal.
25 times 3 equals 15. Oh, 20, that's 75. Yeah, right here.
Okay.
So when you minus that, that will be negative 2 by the reciprocal, by the square root of 3 plus 5 by the square root of 3 all squared. And when you do that, that would be 3 partly squared. And we're not done yet. We still have the squared, so make sure you got that. 9 squared by, 9 times 3, and that equals to 27. 27 is our answer. We got that. You got that. That's a good explanation. Let's move on to our final, and this one, our most hard question. Okay, if the expression below equals to an integer, what is the smallest possible value of n? Square root of 3 over 1 times 4 over 2 times 5 over 3 times ... times n plus 2 over n. Trying to find the smallest. Okay. Well, you see what we have to do. Okay. So let's try if n equals 1. That would be 3 over 1.
So can you write the complete formula first? That they give in the in exercise, yeah.
4 over 2. Sorry.
Yes, exactly.
N is equal to what? Times 5 over 3. ... N plus 2 over n. Okay, so now we're trying to find what is n. Okay, let's do it.
What is the smallest n
what
number?
is the smallest, what's the smallest integer? Integer.
Such as, what happened? This expression is...
this expression is, if it has to be something that's squared, like 16 squared actually equals to integer. The answer is an integer. And
okay, so this...
Yeah. So for this one, it would actually be... This one's actually 1. This one is 1. That's 2, and that's 3. So what we're trying to find is a number. Okay, so let's try 3. Reciprocal, if you find the square root of 3 for 1. For that would, this isn't 1. 1 plus. That would be square root of 3. That does not equal to an integer, so 1 does not work. How about 2?
Write it down.
Yeah, I know, I will. So square root of 3 over 1 is equal to the square root of 3. So 2n. So we still have to 3 over 1 times 4 over 2, because we're supposed to do that, which then that's 12 over 2, which that's equals to 6. That does not work. So let's try 3. 3 over 1 times 4 over 2, 3, which equals to 6 over 1 times 5 over 3, which then equals to 30 over 3, which then that equals to 10. 10 does not work, so 3 does not work. So 3 is just...
Square root of 10, square root of 3, square root of 6 are not an integer. That's why it doesn't work.
Yeah.
Okay.
These don't work. So n equals 4. Square root of 3 over 1 times 4 over 2 times 5 over 3 times 6 over 4. You probably don't see it, but it's 6 over 4. Because 5, 4, and 4, yeah. Which then equals to 10 over 1 times 6 over 4, which equals to 60 over 4, which equals to square root of 15. Square root of 15 is not an integer, so 4 does not work. Let's try 5. So 3 over 1 times 4 over 2 times 5 over 3 times 6 over 4 times 7 over 5 equals to 15 over 1 times 7 over 5, which equals to, what's 7?
Square root of
yeah,
this.
Yeah, square root. I forgot. Let's see, you would have to do 4. 4 is 60 plus that. That would be...
15 is what? Is 3 times 5 or not?
Yeah.
So can you use it there? 15 is 3 times 5.
Oh yeah, so doesn't that mean... Oh yeah, so we can cancel out the... So that turns into 3, take out the common factor of 5. Then that's 21 over 1, which equals to 21. Square root of that. That does not work, so 5 does not work. Hey! You guys see something? Because I do. 3 plus 3 is 6. 6 plus 4, so basically from 3, 4, add 5, and add 6. So we now know. So how do we make a positive integer? So what would work? So the next one would be 28. 28 does not work. 28. So that's 3, 4, 5, 6. That'd be 7. Plus 8 to 28, that would be 36. And that means 36 works.
So you need to prove it. You
Yeah,
need to
so
do
this
n
is-
equals 6, 8 or whichever.
Yeah, so that's
or
so
7.
36. So it's 1, 2, 3, 4. Okay, so
So write the equation
1, 2,
for
3,
n equal
4, 5.
for n equals 6.
7. So yeah, 7. So 7. So we have to do that equation. 7. So n equals 7. Yeah, I know. I really have to write that. 3 over 1 times 4 over 2 times over 3 times 6 over 4 times 7 over 5 times 8 over 6 times 9 over 7. Okay, with the 7 over 5, this equals to, that equals to, which is the same thing as 21 over 1 times 8 over 6. Oh, let's do these. Those would be, give me a moment, sorry. 42 over 72. But then if you simplify...
For n equal what, you find 24. It's 21 times... Yeah, okay, you're right. Times 8, times 8 over 6, times 9 over 7. Okay. Can you do some simplification there? 21 is 7.
Oh yeah, this would... Then we can change this to 4 over 2. No, or...
No.
4 over 3.
Yeah, it's better.
We can turn that to 4 over 3. When we multiply it, that would be so much easier. That would be 4... No, that would be 84.
No, look. Under 7 times 3 equal what?
21.
What do you have on the top?
21. Oh, so we can cancel these. How convenient. And then it's 36 over 1, which then equals to 36, which then equals to 6. It's a positive. It's an integer, finally. And turns out their answer is 7. Woo! That's a lot of math today. So this is great math, and if you did like this video, please do subscribe, and please do give a big thumbs up to Great Math and all the other videos that we have done. Don't worry, we haven't just done Great Math, we've done other stuff also. And yeah, that seems about it. And yeah, I'll see you later. Goodbye.